Okay, what up, kids? Sorry, this is 10.2. I say sorry because you have to sit here and listen to this and not have a chance to ask questions. So please mark down anything that seemed weird during the video that you didn't get, and write down your questions, and we'll try to clear it up next time I see you. But anyways, we're doing the same exact stuff we did last section, except we're doing it with means. Okay, so just like before, when we played with proportions, we could do z-scores, we could do z-stars, we could do normal CDF. That's proportions, 10.1. Now granted, we did most of it in the calculator, which I get, I'm good with. But now that we switch to means, we've got to remember that we have to deal with X bar, S, degrees of freedom. And now that we have two samples, it becomes even more of a pain in the tuchus. So anyways, and again, we don't have time to do this well. But the fact that we have two independent random samples is so important, because we did a problem a few days ago that talked about before and after. It was a matched pairs problem. And that matched pairs problem we did based on the difference between the two, which is exactly the same idea that we're talking about right now. The differences between matched pairs and two sample is that we have independent random samples as opposed to not independent random samples. And not gonna lie, that's one of those that took me a while to get good at. I missed many a problem trying to decide if these two samples were independent or not. And I'll talk about it a little bit, but it's rough. Do your best. Worst case scenario, you do a matched pairs problem as a two sample problem. You could still theoretically get a 3 on the AP exam. Sorry, a 3 on that question of the AP exam. So, and a 3 is a win. 2s are our goal. I don't know if I've talked about that enough, but a 2 is generally a win on an AP exam question. Question, not total score. So, that being said, I don't want to get too crazy about this, but we still have to say, just like 10.1, independent random samples. We still have to talk about each population being more than 10n. And again, all that is I don't know, I hate to say it's busy work, but it's like you got to write it out, letting them know you know what you're talking about. And then this is the hard one, approximate normality in the sampling distribution for each group. So, in T problems, if you remember, we had 3 options for the third assumption. Oh, I already wrote ANSD. So this is your third assumption. You already checked 1 and 2. In ANSD, approximate normality, we could be, n being bigger than 30. Now the problem is we would have to have 2 n's being bigger than 30. Now the reality is, and this is annoying, each group doesn't need to be bigger than 30. The total needs to be bigger than 30. Which again, 30 is such a vague number, it drives me nuts. Or they can tell me in the stem of the problem that ANSD is okay. Or, which I'm going to show you, which is evil and brutal, and I can't believe they did it, you have to make graphs of each. set of data, and then talk about the same thing we did in Chapter 9. Since there are no outliers or severe skewness, I'm going to assume approximate normality. I mean, it's brutal. And the problem I'm going to show you is literally a AP free response question. So, is it common? No. Could they ask it? Yes. All right, so that's the assumption piece. When we're playing with means, two sample mean problems, we are either looking for the difference between their averages, the average SAT score for a Nevada student versus the average SAT score for a Wyoming student. Or we're checking to see if does the average SAT score for a Nevada student equal the average SAT for a Wyoming student, and then our HA would be whatever we think it is. So I think Nevada kids are stronger in the SAT than Wyoming kids. Or I could think they were weaker than Wyoming kids. Or I could just see, are they different? So that, again, that comes down to the greater than, less than, not equal to dilemma that we'll get with all of these. Okay, so again, to save time, I have already done these problems, and so you're not sitting there watching me write. I'm going to walk through it, but you likely need to pause and write it down, or watch it twice. Or, I mean, I don't know what to tell you. I'm trying to keep the video down so it's not obnoxious, but the reality is there's a lot that goes on in these problems. So don't be afraid to pause it, write stuff down, and then listen. That's what I would argue is the ideal. So anyways, we're talking about two different pet stores. We're trying to see if the fish from Fish Friends were, hang on, maybe I'm wrong. No, hang on. Talking about Fish Friends versus Buy Right. Okay, who cares? What they really asked was, do I have convincing evidence? And that statement should lead you to believe I need a p-value. The fact that we need a p-value means I need a ho-ha problem. And they specifically asked, we think Fish Friends is bigger than Buy Right. Okay, so first thing I think you need to think about is what kind of problem is it? It's a test. It is a mean problem, which means it's a t-test. So that's multiple decisions right there that you kind of got to think about, because what we did last section was all proportion problems, and that changes some of the dynamics of the problem. The last thing you got to think about, which is highly underrated, is this two sample or is it matched pairs? And again, like I talked about it earlier, that's not easy. Again, worst case scenario, you do it wrong. If you do all of the other pieces right, you'll still get a good grade. Okay, I'm going to start with ho and ha, even though I probably should start with assumptions. So we are talking about, is the mean, mu, length of fish at Fish Friends the same as Buy Right, or is the mean for Fish Friends greater than Buy Right? And again, I hope, sorry, I keep saying and again. It's driving me nuts. I can't imagine what it's doing to you. You could theoretically have said this, and I kind of did this intentionally, but you could have said the mean for Buy Right is less than the mean for Friends, especially since Buy Right came first in the problem. So I really don't care which way you go about it. Who are you going to put first? Who are you going to put second? But as I mentioned in 10.1, it does matter in terms of how you plug it into the calculator and how you define your alternative hypothesis. So, I was trying to find fish friends bigger than by right. Got to define mu for fish friends. Got to define mu for by right. Details that are important. I mean, it sounds like I'm being OCD and crazy, but we can't just say fish. Are we talking to bass or are we talking to minnow? I mean, so I think the more detail you put in the communication, the more they will reward you. Likewise here. Then, I can summarize. Oh, sorry, let me back up, because I like how this problem sets up. That's why I kind of did it. They gave you the actual data, the actual length of 8 fish and 10 fish. And I can't remember if I told you this in the last video, but why aren't they the same? Why didn't you do 10 for each? It doesn't matter. I think in a normal, rational person's mind, we would do the same for each. However, it doesn't make a difference. The math that we're learning accounts for a difference in sample size. So, that being said, this is really what I care about. This is my x bar and x bar. Why is it not mu? Because it's a sample. This is my S. This is my S. Because it's a sample. And what I'm saying is, why isn't it mu and sigma? Because that's just that sample of fish. Okay, and I'm trying to see if, does this difference, so as I look at it, it looks like fish friends have longer fish. But is it big enough for me to be convinced that on average, fish friends has bigger fish? And that's what I'm really trying to find out. So I summarize that information, and you might think that whatever, they already did it in the table. No, you redo it. You communicate that you know what X bar represents, what S represents, what N represents. And the way I set it up is I started with fish friends, even though that was second, and this is kind of what I'm trying to talk about. Even though that was the second one, because of how I set up my ho-ha, I wanted to see if fish friends was bigger than by right, so I chose to start with fish friends. If you were to choose the other way, there is nothing wrong, just like last time, you just have to be careful. And make sure you're being consistent with how you plug in your data, your stats is what I should say, versus how you set up your ho-ha. Then, I'm going to talk about assumptions. Just like last section, got to have the word independent. You don't have it, they won't give you full credit. This is not a matched pairs problem. Therefore, these samples are independent of one another because one was from one store, one was from a second store. Those are independent samples, as opposed to, like if I wanted to find out whether or not this type of fish was bigger than this type of fish, and I paired them up. And it's a very fine line, as all I'm telling you. Moving on, I got to check that both populations, being a little lazy here, are more than 10N. All fish of this species at fish friends, because I got two populations that I got to talk about, is more than 10N. And because my samples were different, I got to be a little bit careful. All fish at fish friends is more than 100. All fish at by right is more than 10 times 8. So I am assuming, which they did not give me any information about, I am assuming it's more than 80. If it wasn't, then the rest of my math makes no sense. So, again, we call these assumptions for a reason. Here's where it gets real ugly. And this is a legit AP free response question. And again, I'm not going to say it's common, but it's feisty. In order for us to talk about approximate normality, we either need, I talked about it earlier, sorry, maybe I talked about it earlier. Oh, yeah. We need one of these three things to be true. And in this case, my samples were not bigger than 30, and my total was not bigger than 30. They did not tell me that fish lengths were approximately normally distributed. So you would have, in order to get full credit for this problem, had to graph each set of data and then talk about there being no outliers or severe skewness. So I did it painfully. And I got to be honest, if this was a real AP exam, I don't know if I would have the patience to grind through all of this. I mean, you look at the third assumption on its own, and it's 4 or 5 minutes. And I don't know. I'm just showing it to you. You make your own decision about what you want. But I am checking to see if it's approximately normally distributed. Sorry. My ends were not big enough, so I graphed fish friends. I looked at that graph and said, hey, it doesn't look normal, but I don't need it to look normal. It doesn't look like it's got freakish outliers or skewness, so I think I'm good. I did the same thing with Byrite. Nothing looked cray-cray. And again, you guys might think, oh, those look like outliers. Part of a normal distribution is, especially when you only have 8 pieces of information, they're pretty balanced on both ends. Yes, these guys look kind of cray-cray, but so do those guys. Therefore, I'm not going to panic. And this is technically what you'd have to say. I'm asking a lot right here is all I'm telling you. This is, for you to be willing and able to do this would make me a proud papa. So, don't panic. I'm just showing it to you. More importantly, ho-ha critical. Summarizing my data, critical. Correct notation, critical. I've got some subscripts, and if you want to use 1 and 2 instead of F and B, that's fine. I would just argue that, especially since they did it this way, it might be better for you to do it this way. But they wouldn't mind, as long as you defined mu1 to be fish friend, or whichever way you went about it. But mu1 is this, mu2 is that. As long as you communicate that, they'll be okay with it. So I summarized the information they gave me in the table. Now, I chose a 2-sample mean t test. The way they say it in the calculator is just 2-sample t test. But that's what I chose when I went to stat tests. I plugged in my first mean, my first standard deviation. And this is where, when I say first, it kind of matters how you set it up. Somebody else could have done Byrite first and then chosen less than. And that would be absolutely correct. So you just got to kind of be careful of how you plug it in and what your HA is. If it's not equal to, it don't matter. It's going to be the same either way. But if it is greater than or less than, it makes a difference and you need to be a little careful. Anyways, plugged in my X, my S, my N for each group. I got a T-score, meaning that's how many standard deviations this difference was away. Well, if I look at that, that's 0.26. That's a pretty small number of standard deviations. It's less than 1. In fact, it's less than a half of a standard deviation. So in my mind, just thinking right now, I got no evidence that they're different. They were close enough that I have no proof. Now, here's the cray-cray part. There is a fancy schmancy formula. You can look at it in the book. It's like whoever came up with this is more brilliant than me. Well, that's not hard. Is brilliant. But if you have a 2-sample problem, there is a fancy formula that finds degrees of freedom more technically. It gives us a bigger degrees of freedom than our old school n-1, is all I'm telling you. So there's my t-score that we talked about. There's the p-value that I listed up here. And I must communicate degrees of freedom. If you round that, there's nothing wrong with that. From there on, it's the same as we've done. Compare your p-value to alpha. And I want to emphasize, I had some good questions today. Don't just say using an alpha 05 level or using an alpha 01 level. You've got to actually compare your p-value being bigger or smaller. If you just say using, they don't know if you know what that really means. So they want you to say using, because our p-value, sorry, I just said using, because our p-value is bigger than alpha 05, don't care if you chose alpha 01, I do not have enough evidence to reject tau and cannot say that the details true mean length of this species, and again, I might be getting OCD with it, but I'm trying to give you the best chance you can. The true mean length of this species from fish friends is bigger than that of those from Byrick. So again, details you got to include. If I say so again, I'm going to be real mad at myself. Ho-ha. Summarize info. Check assumptions. Name the interval. Like I said with proportions, I think the math behind this becomes pretty overwhelming. I'm going to show you the formulas, but I just don't know if it's really worth your time. Grind out, in this case, I should say this case because the next problem we're going to do a confidence interval, the t-score, the degrees of freedom, and the p-value. And then it's the same as we've been doing. If your p-value is big, can't reject tau, can't accept tau. If your p-value is small, reject tau, accept tau. Again, please just mark anything where I'm saying something that you don't really understand what's going on. There's one more choice in this, when you do your 2-sample t-test, they ask if we're pooling it. Never, 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 never pool it. Now, why do they ask it then? The only way we could pool it, and you might see this as you read free response answers, is if we believed those were the same. If you had some reason to believe the 2 standard deviations were the same, then you could pool it. And there's some advantage to that, but I have never seen that as an issue. So I'm going to say just always leave this guy as no. And if you paid attention to the last video, we always pooled the proportions just automatically. You didn't have to make a choice. I'm just saying don't ever make the choice of pooled. Just trying to help you out. Make things simple. Okay, next one. Oh, I'm getting short on time. So here are your formulas. This would be the formula for the test statistic. That is the standard deviation. For the difference, in the means of two samples. Sorry. Which they give you on your formula sheet. But the reality is I just don't see you using that. Now, could it be a multiple choice question where they set it up? Sure, could be. And that's the only reason I'm really showing it to you. Where's my notes? Okay, so that would be where I got my t-score from. From there, I could go to ghetto table to find my p-value. My advice to you, especially in this year, is let the calc do the work. Let the calc find your t-score. Let the calc find your p-value. It is a very rare question where they make you do that without the calculator. Not saying it won't happen, but I'm just telling you. I would argue this formula is a little bit more common. If sorry. If I wanted a confidence interval for the difference, so the first problem we did was talking about, do you have evidence of a difference? This next problem is talking about how much is the difference between the true mean of whatever freshmen versus the true mean of sophomores. And if you're looking for that, here's the formula for the confidence interval. And again, it's very similar to what you've played with. In chapter 8, we did this. That was our formula for the confidence interval for a mean of a one sample problem. Well, it's the same idea. It's just, oh, I just noticed this. I don't know if it's on your notes or just my flip chart, but those should have bars over them. That should be x bar 1 and x bar 2. Anyways, we're not talking about just x bar. We're talking about the difference between those x bars. We still have a t star, and our standard deviation just got more complicated because we have two samples. Now, they don't give you those formulas that nicely, but structurally it's the exact same as we've played with before. I do want to kind of talk about this because, I don't know. If, theoretically, you were forced to do something by hand, we could use what I like to call ghetto, the more conservative, not fancy formula. Degrees of freedom of, I don't know how big his sample is, but I could minus 1. I don't know how big his sample is, but I could minus 1. And whichever one is smaller, I could use that as my degrees of freedom. I just don't know what to tell you. I think that's ridiculous just because you've got technology. If you were really doing this, you would never do that. So, whatever is what it is. Sorry. Okay, so now we're switching gears. We're talking about sixth grade students versus 7th grade students. And they have given us the mean and standard deviation for each group. I have summarized that information, and you would need to. You'd be surprised how important notation is. So I got my 6th graders, their mean, standard deviation, and n. 7th graders, mean, standard deviation, and n. And again, the n came from up here. I know I'm going fast. You're going to have to pause. You're going to have to rewind. I'm sorry. But I'm already pushing 30. I would still need to check my assumptions. Go ahead and pause, write them down. In this case, ANSD is a little bit sketchy. Because the total is more than 30, we're good to go. I just said both samples are relatively large. That would be sufficient. They really just care, do you know what we're supposed to check and what would it mean? Why do we check it? So don't panic about that. Again, summarized. We want, actually I need to come back to here. They wanted us to estimate the difference in the mean times. We're not checking to see if there's a difference. We're checking to see how big the difference is. And if you look at these two means, I think it's fairly obvious to argue that there's a difference. I could run a test, get a p-value, prove that there's a difference, and then find out how big the difference is. But the reality is they're asking how big this difference is. So, in this case, we're calling this a two-sample mean t interval. And again, the organization of your subtraction is kind of important, and you got to communicate it. I chose to plug the 6th graders in first, and then the 7th graders. If you would have done opposite, your interval would have been positive. So it would have been positive 12.25 to positive 27.15. And all that is the difference between which way you wanted to subtract. I would tend to argue that I like to keep numbers positive, but it really doesn't matter. You could see both, so don't panic. So the name of the interval, two-sample mean t interval, grinded it out in my calculator, plugging the exact same data in that not same data, using the exact same information that I used on the last problem. Cray degrees of freedom again. Okay, so be it. If you rounded this to 37, they wouldn't care. And then communication. Much like last time, 95% confident. True mean. Difference. We're not talking about the mean for the 6th graders. We're not talking about the mean for the 7th graders. We're talking about how different they are. And the true mean difference between the amount of time 6th graders, one group, spent on homework, context, location, aka population, is between 12.25. Whoa, where'd your negative go? I need to know, as a smart lad, that all this negative means is less than. So I said it's between 12.25 and 27.15 minutes, units, less than. There's the negative right there. If I would have done it the other way, if I would have switched these guys and plugged 7th graders in first, like I said, my interval would be positive, and my communication would have been 7th graders more than 6th graders. And it doesn't matter. But again, talking about the mean is pretty important. Each subgroup, pretty important. Population of interest, pretty important. And again, like I said, this becomes an English class. Okay, very quickly, I'm just going to show it to you in case. You might see this in multiple choice. Just the setup of what you would do if you wanted to do it by hand. If you notice the way I set it up this time, I did 7th graders first and 6th graders second, just so I could end up with my positive values. It doesn't make a difference as long as you know what you're talking about. Why is my answer different? Slightly. Because I used the ghetto n minus 1 degrees of freedom, which if you're doing it by hand, that's fine. But if you have technology, why wouldn't you use it? So, we're not off by a ton, just slightly. But that's what it might look like by hand in a multiple choice question. Okay, so take these notes. I'll post the homework for 10.2. Make sure 10.1 is done. I know we're going fast. It is what it is. I'm trying to help you as much as I can. Please don't panic. I'm not freaking out about the AP exam, but I also want to give those people who are interested the best opportunity. So, take care. Sorry, I went over my 30-minute limit. Have fun. Bye.